our next problem for the first order linear differential equation is dx over dt plus 3x is equals to t. So as you can see, this is now a non-homogeneous equation in the form of non-homogeneous. So we'll try to make this into a homogeneous equation. Now by doing that, dx over dt plus 3x, we will equate this into 0. Now this is your homogeneous equation. So combining the like terms, so dx is equals to negative 3x dt, and then 1 over x, dx is equals to negative 3 dt. Now we will integrate this. Integral of 1 over x dx is equals to the integral of negative 3 dt. So we know that 1 over x is equals to ln x is equals to negative 3t plus c. And then raising this to the power to the e, so e to the ln x is equals to e to the negative 3t plus c. Now this becomes x is equals to e to the c times e to the negative 3t. Now we let this constant that we get to vary. So we will let this vary with t. So x of t is equals to k of t times e to the negative 3t. Now this is your solution for the homogeneous solution to homogeneous equation. So x of t is equals to k of t times e to the negative 3t. Now next is we will try to plug this into our non-homogeneous equation, which is our non-homogeneous equation. As you can remember, this was dx over dt plus 3x is equals to t. Now this was your this is your non-homogeneous equation. So we will try to plug our solution to h into the non-homogeneous equation, but we didn't know what is the dx over dt. So we'll try to derive this before plugging this in. So the derivative of k of t times e to the negative 3t is equals to, so dx over dt is equals to the derivative of k of t times the e to the negative 3t. So k of t times negative 3 times e to the negative 3t plus the e to the negative 3t times the derivative of k of t, which is k prime of t. Now we have our dx over dt, and then we will input that into the non-homogeneous equation. So the equation becomes negative 3 e to the negative 3t plus e to the negative 3t k this is equals to dx over dt is equals to k of t times 3 e to the negative 3t plus e to the negative 3t k prime of t plus 3. Our x is the solution of the homogeneous equation, so 3 times x, which is equals to 3 times the k of t times e to the negative 3t. So is equals to t. Now, if you can see, as you can see, this is negative 3. So, you can cancel this equation. So, the remaining would be e to the negative 3t k prime of t is equals to t. And then, we'll try to solve for the k prime of t, which is equals to t times t e to the 3t. Now, the integral of that is k prime of t is equals to integral of t times e to the 3t. But we cannot simply integral this because we have some indestructible coefficient. So now we will try to use by using integration by parts. That is uv minus the integral of the v du. So the integral of t times e to the 3t dt. So let u is equals to t, then the dt becomes, or the du becomes dt. So du is equals to dt. And then our dv, let dv is equals to the e to the 3t dt. So integrating that, dv is equals to the integral of e to the 3t dt. So we'll arrive at v is equals to 1/3 e to the 3t. So now, substitute that into our formula uv minus the integral of v du. So our u is t times the v is 1/3 e to the 3t, and then minus the integral of 1/3 e to the 3t dt. Now t over 3 e to the 3t minus 1/3 over 3 e to the 3t plus c. So simplifying that equation, t over 3 e to the 3t minus 1/9 e to the 3t plus c. Now this is your k prime of t, k of t. That's your k of t. So you can see, so that was your k of t. And then we will now plug this into our homogeneous equation, which is x of t is equals to k of t e to the negative 3t. Now x of t is equals to, our k of t is 1/9 e to the 3t plus or this is negative 9 now. No. This is 1/3. This is t over 3 e to the 3t minus 1/9 e to the 3t plus c times e to the negative 3t. Now x of t is equals to, so multiplying this, you will get t over 3 minus 1/9 plus c e to the negative 3t. And this is your answer, or this is your solution. Okay, another example. But before that, we will try to recap. So, our equation is dx over dt plus 3x is equals to t. So, that is now a non-homogeneous equation. So, we'll try to make that as a homogeneous equation, which we will equate that to 0. So, dx over dt plus 3x is equals to 0. And then dx is equals to negative 3x dt. Then this becomes 1 over x dx is equals to negative 3 dt. And now integrating that, 1 over x, the integral of 1 over x dx is equals to the integral of 3 dt. Now the integral of 1 over x is ln x, and then the integral of negative 3 is 3t, negative 3t plus c. And then, raising that to e to the ln x is equals to e to the negative 3t plus c. And then x is equals to e to the power of c times e to the negative 3t. And we'll let this constant vary with t. So, x of t is equals to k of t times negative 3t. So, that is your solution to homogeneous equation. And then, we will try to derive this solution. So, we can obtain the dx over dt in the non-homogeneous equation. So, the dx over dt, or the derivative of k of t times e to the negative 3t is equals to k of t times negative 3 e to the negative 3t plus e to the negative 3t times k prime of t. And then substituting that into our non-homogeneous equation, so k of t times negative 3 e to the negative 3t plus e to the negative 3t k prime of t plus 3 k of t e to the negative 3t is equals to t. Now, we can cancel this out. If you are now in this step, you should have this cancellation, because if you won't have a cancellation like this, then your solution might be wrong, or your integration or your differential calculus might be wrong. So, be sure to check your integral and then your differential, your integration and your differentiation. So now, e to the negative 3t, k prime of t is equals to t. Then k prime of t is equals to t times e to the 3t. Now integrating that, so we can get the k of t. So integral of k prime of t is equals to the integral of t times e to the 3t dt. Now by using integration by parts, because we have some indestructible equation using uv minus the integral of v du. So now we will let u is equals to t, then our du is equals to dt, and then let dv is equals to e to the 3t dt. Now the integral of that is equals to 1/3 e to the 3t, and then substituting that into our equation uv minus the integral of v du, that's become t over 3 e to the 3t minus 1/3 over 3 times e to the 3t plus c. Now simplifying the equation, t over 3 e to the 3t minus 1 over 9 e to the 3t plus c is equals to k of t. That's your k of t. And then, as you obtain the k of t, now you can use that to plug that into our homogeneous solution. So, the x of t is equals to k of t e times e to the negative 3t. So, plugging that in, so t over 3 e to the 3t minus 1 over 9 e to the 3t plus c times e to the negative 3t is equals to t over 3. So t over 3 times e to the 3t times e to the negative 3t is equals to t over 3. And then negative 1 over 9 times e to the 3t times e to the negative 3t is equals to 1 over 9. Then, c times e to the negative 3t is equals to c times e to the negative 3t. So, this is now your solution. So, next example. So, our last example. Our last example is dx over dt minus 2x is equals to sine t. Now this is now in the form of non-homogeneous equation. Then dx over dt minus 2x is equals to 0. Now this is your homogeneous equation. And then trying to solve that, dx is equals to 2x dt. And then 1 over x dx is equals to 2 dt. Now integrating that, 1 over x dx is equals to the integral of 2 dt. That's x. That's ln x is equals to 2t plus c. Now raising that to e to the ln x is equals to e to the 2t plus c. Now this becomes cancelled. X is equals to e to the c times e to the 2t. Now we let this vary. X becomes x of t is equals to k of t times e to the 2t. Now this is your solution to H, to our homogeneous equation. Now we will try to derive that. So we will try to derive this x of t, k of t times e to the 2t. So we will now have dx over dt is equals to this becomes k of t times 2 e to the 2t plus e to the 2t times k prime of t. So k prime of t. Now that is your dx over dt. Now we can plug this into our non-homogeneous equation, which is our non-homogeneous equation is dx over dt minus 2x is equals to sine t. Now plugging the answer, k of t times 2 e to the 2t plus e to the 2t times k prime of t minus the 2, our x is k of t e to the 2t, that is k of t e to the 2t. Okay, is equals to sine t. Now as you can see, we can cancel this out. Cancelled. So the remaining, the equation is equals to e to the 2t times k prime of t is equals to sine t. And now k prime of t is equals to e to the negative 2t sine t. Now integrating this, k prime of t is equals to the integral of e to the negative 2t times sine t. Now we can use the integration by parts, but if you have other method in integrating this, it's good. So by using integration by parts, so e to the negative 2t times sine t. So the integral of that is, we will let u is equals to, let u is equals to e to the negative 2t, and then our du, so our du becomes negative 2 e to the negative 2t dt, and then our dv is equals to the integral of, so integral of sine t dt. Sine t dt. And then this becomes v is equals to the sine t dt. So our integral of sine t dt is equals to negative cosine t. Now plugging this out, so into our uv minus the integral of the v du. Now we have e to the negative 2t times negative cosine t minus the integral of negative cosine t times negative 2 e to the negative 2t dt. Now we have this indestructible integration again. So now we will use again our integration by parts. So by using integration by parts, so integral of the negative cosine t times we will try to arrange this. So before that, ato sang i-arrange. So i-arrange na nato ang constants. So this becomes e to the negative 2t times negative, this becomes negative e to the negative 2t cosine t plus or minus, so minus 2 integral of cosine t e to the negative 2t dt. Now we will let this, so let u is equals to e to the negative 2t, and then our du becomes negative 2 e to the negative 2t dt, and then our dv is equals to the integral of the cosine t dt. Now our v becomes integral of cosine t is equals to sine t. So uv minus the integral of the v du is equals to our u is equals to, now this equals to e to the negative 2t sine t minus the integral of sine t times negative 2 e to the negative 2t dt. Now simplifying that, e to the negative 2t sine t, so negative times negative, that's positive, positive sine, that's 2, positive sine t e to the negative 2t dt. Now we will try to so that was your cosine, that was your integration of the cosine, this was your integration of this. So we will try to plug that in. So this becomes, the equation becomes negative so e to the negative 2t sine t dt is equals to negative e to the negative 2t cosine t minus so di kay go, so e to the negative 2t sine t dt is equals to negative e to the negative 2t cosine t minus 2 times e to the negative 2t sine t plus the integral of 2 e to the negative 2t sine t dt. Now this is your, now we can, now multiplying this, so 2 times that will become e to the negative 2t sine t dt is equals to negative e to the negative 2t cosine t. So 2 times, so you would try to multiply that, so that becomes minus 2 e to the negative 2t sine t minus 4 times the integral of e to the negative 2t sine t dt. Now as you can see, we have this common term, so we can use that as a variable. So now this becomes 5, so 1 plus 4 is equals to 5 integral of e to the negative 2t sine t dt is equals to negative e to the negative 2t cosine t minus 2 e to the negative 2t sine t. Now your integral e to the negative 2t sine t dt is equals to 1/5. This is negative 1 over 5 e to the negative 2t cosine t minus 2/5 e to the negative 2t sine t. So now that is your integral of e to the negative 2t sine t dt. Now your k of t is equals to negative 1/5. So this is your k of t now, negative 1/5 e to the negative 2t cosine t minus 2/5 e to the negative 2t sine t. So you'll have a plus c here, plus c. I try to rewrite that para makita. So k of t is equals to the negative 1/5 e to the negative 2t cosine t minus 2 over 5 e to the negative 2t sine t plus c. Now trying to plug this into our homogeneous solution, which was x of t is equals to k of t times e to the 2t. Now x of t is equals to k of t, the k of t is negative 1/5 e to the negative 2t cosine t minus 2/5 e to the negative 2t sine t plus c times e to the 2t. So now x of t is equals to so you'll try to multiply that. So 1/5, negative 1/5 negative 1/5 times e to the negative 2t times e to the 2t is times cosine t. So e to the negative 2t times e to the 2t is 0. So e to the 0 is 1. So minus 2/5 sine t plus c e to the 2t. Now this is your solution. So recap, let's recap that. So our problem is a simple problem. So dx over dt minus 2x is equals to sine t. That's our non-homogeneous equation. Then we will try to form that into a homogeneous equation. So we will equate that into 0. So that would become dx over dt minus 2x is equals to 0. And then we will try to arrange that, and we will arrive at 1 over x dx is equals to 2 dt. So now we can integrate this. So integral of 1 over x dx is equals to integral of 2 dt. And then the answer would be x is equals to e to the c times e to the 2t. And then we will let vary our constant that we've got. So this becomes x of t is equals to the k of t times e to the 2t. So that's your solution to homogeneous. And then we will try to derive this. So dx over dt is equals to k of t times e times 2 e to the 2t. So then the differential of this, so 2 e to the 2t plus e to the 2t times k of t. And then dx over dt is equals to sine t, which is our non-homogeneous equation. So we will try to plug this. We'll try to plug that. So k of t times 2 e to the 2t plus e to the 2t times k of t, k prime of t minus 2 times k of t e to the 2t is equals to sine t. Now by doing some math, we can cancel this out. So the equation becomes k prime of t is equals to e to the negative 2t times sine t. And then integrating that, integrating this, e to the negative 2t times sine t. So by using integration by parts, so let u is equals to e to the negative 2t. Our du now becomes negative 2 e to the negative 2t dt. Then our dv, let dv is equals to integral of sine t dt. Then the integral of that is equals to negative cosine t. And then substituting the answers, so e to the 2t into the uv minus v du. So e to the negative 2t times cosine, negative cosine t, minus the integral of negative cosine times negative 2 e to the negative 2t dt. Now we have another indestructible equation. So now we will use integration by parts again. So let u is equals to e to the negative 2t. Then our du becomes negative 2 e to the negative 2t dt. And then dv, let dv is equals to integral of cosine t dt. Then the integral of that is sine t. Then plugging that in into the uv minus the integral of v du, that's become e to the negative 2t sine t minus the integral of sine t minus 2 e to the negative 2t dt. And then e to the negative 2t sine t plus 2 integral of sine t e to the negative 2t. That is your cosine, the integral of cosine t e to the negative 2t dt. So we will try to plug that out. So substituting that into the equation. So the integral of e to the negative 2t sine t dt is equals to e to the negative 2t cosine t minus 2 times e to the negative 2t sine t plus 2 integral of e to the negative 2t sine t dt. Then by doing some math, we'll arrive at 5 integral of e to the negative 2t sine t dt is equals to negative e to the negative 2t cosine t minus 2 e to the negative 2t. And then our integral of e to the negative 2t sine t dt is equals to 1/5 negative 1/5 e to the negative 2t cosine t minus 2/5 e to the negative 2t sine t. And then that's our k of t. So we will try to plug that into our homogeneous equation solution rather. So x of t is equals to k of t times e to the 2t. So now we will arrive at the answer x of t is equals to negative 1/5 cosine t minus 2/5 sine t plus c e to the 2t. Now that is your solution. Okay, good luck next exam. Thank you.